Is it working?
Exactly.
I don't want to look. Is it working?
No, but that's
It's working?
yeah, it is.
All right, guys, find your seat here. We'll get going.
Let's go back. White coffee's green, but black coffee's not.
All right, guys, just a quick reminder then. Take-home quiz tomorrow, beginning of class. Don't forget that, okay? And then the 7.4 assignment that I sent out to you, they'll be due, what is it today, Wednesday? So due Friday, all right? Okay, so sorry about the delay in this. You got a little bit of a break at least, right? Right? Mm-hmm. All right, technology's great. What? No.
Like computers.
All right, guys, we're gonna start looking at two-way tables. Basically, talking about dividing stuff up. Let me ask a question here. What age is everybody the same age in here, or are there different ages of kids? Okay, different ages of kids. So there might be some kids that are 14, some kids that are 15, so on. And then some of you guys are boys and some of you guys are girls, right? So we can start talking about looking at tables of information and dividing stuff up where we're talking about a certain number of boys a certain age or a certain number of girls a certain age. And that's kind of what we're going to be dealing with today, looking at two-way tables. Now, there's going to be a lot of vocab in here. It's very difficult. I'm going to try my best to simplify this. And it's probably to your advantage to make sure you take good notes with this today. But 7.4 is titled Two-Way Tables. And we need to know how we can read and make two-way tables here. Or to do that, we've got to look at what we're going to talk about here in our goals. So if you're here with me on the goals right here, first one for me is to find and interpret marginal frequencies. That'll be something we talk about here in a second. We're going to go ahead and construct some two-way tables. This is where things get sort of difficult. We're going to look at finding what we call a relative and a conditional relative frequency. And then we're going to look at those frequencies and use a two-way table to recognize associations in data. We're looking for some type of a trend, if you will. Okay. So I just want to read through the vocab. I'm going to kind of put some shortcuts up here, and I think that as we move through the examples 1 through 5 today, I really think that the vocab will make more sense to you. So, two-way table right here. How about a volunteer to read that first definition for me? Volunteer to read that first definition. Go ahead, Kaylee.
A frequency table that displays data collected for one source that belong to two different categories.
Okay, so how many categories are we really talking about now? Two of them. Talking about two of them. All right, and then joint frequency. Okay, a joint frequency says it's each entry in a two-way table. Basically, I'm going to write this down here, guys. It's going to be the numbers in the table. Whoop, that'll work. No, it's not going to work. I'll write it this way. It's going to be the numbers in the table for you. So you might want to write that down there, okay? Numbers in the table. All right, it's just the numbers in the table. So if I say, hey, what are the joint frequencies? It's just be the numbers in the table. So it might be like, how many girls are 14? That's a joint frequency, all right? Joint frequency, because it's girls and age is 14. All right, marginal frequency. It's going to be the sums of the rows and the columns in a two-way table. Sum of the rows and the columns in a two-way table. Basically, this is the total group size, if you will. It's the total size, if you will. Okay, marginal frequencies are going to be the totals of each column and each row. All right, we're going to have a term called joint relative frequency. And joint relative frequency basically is the ratio of a frequency that is not in the total row or total column to the total number of observations. Basically, it's going to be one of your joint frequency numbers divided by a total group size. All right. And then when we start talking about those totals, we always start talking about those totals as they relate to a percentage, and that's kind of what marginal relative frequency is. Marginal relative frequency is a percent of your joint relative frequencies as a decimal. And I'll show you what that means in an example here. So I'm just putting up some notes here to try and make this shorter. When I say marginal relative frequency, I read this right here. The sum of the joint relative frequencies in a row or a column. Which one makes more sense? Percent as a decimal or the sum of the joint relative frequencies in a row or a column? Which one makes more sense, mine or theirs? And the one in red does, doesn't it? Okay. And we'll talk about conditional relative frequency here at the end, and it's just basically the ratio of a joint relative frequency to the marginal relative frequency within that row or column. Okay. You'll understand this. A lot of terms right here. Joint relative frequency, marginal relative frequency, conditional, marginal, joint, all relative frequencies. I'll show you the difference here in a bit. Okay? Let's get going on this. La la la. La la la. Ooh. Example 1. Volunteer to read example 1, please. Volunteer to read example 1, please. Thanks, Kelly.
The two-way table shows the results of the survey that asks students whether they ride the school bus. Find and interpret the marginal frequencies for the two-way table.
Find and interpret the marginal frequencies for the two-way table. Marginal frequency meaning what, guys?
Total size.
Total sizes, okay? Here, guys, we have number of kids that ride the bus. Okay, kids that ride the bus. That's the question. Do the kids ride the bus? And then over here, we've got some classes, some juniors and some seniors. Now, one would expect as you get older, you might start driving, meaning you're not riding the bus. Okay? So in this table right here, put my line right there. In this table right here, kids, we're asking ourselves the following. Can you find the marginal frequencies? In other words, the totals for this right here. Well, as we read this right here, guys, the joint frequency of 38, this just means the number of juniors that do or do not ride the bus. Okay, so the joint frequency of 38, that number 38 represents the number of juniors that ride the bus. What's the joint frequency of 44 mean up there, guys? Or gals? That number 44, what's its joint frequency? What's that joint frequency of 44 mean? It's the number of that do not ride the bus. You've got that, okay? Guys, getting totals here, pretty easy to do, okay? How many juniors are in a class? What would you do with the 38 and 32, kids? Add them up. What's that add up to?
80.
Careful.
70.
70. All right, so there's 70 of them. 70 juniors surveyed. How many seniors were surveyed?
65.
60 what?
5.
65. Quick question here, kids. What's the total group size then? How would you find that?
You would add 70.
Add 70 and 65, 135. This 135 down here is your overall total group size. It's your total group size. This number right here represents the total group. Now we may use the total group value a lot, we may not use the total group value, okay? Let me ask this question right here. How many kids are riding the bus? Could I figure that out with a column? How many kids are riding the bus, regardless if they're a junior or senior? What would you do with the 38 and 21? Add them up, 38 and 21. Well, what is that, 59? Okay. How about 32 and 44? What's that add up to?
76.
Somebody punch 76 plus 59 in. Tell me what you've got. 135. What do you notice about this sum right here and adding these values up?
They equal the same thing.
Each time they add up to 135. Guys, right here, finding and interpreting marginal frequencies. Marginal frequencies are just totals, okay? They're just totals. So everything highlighted in green right here, everything highlighted in green is a marginal frequency. Every total is going to be considered a marginal frequency. All right, so when I use this fancy smanchy term, say, what's a marginal frequency? You're going to be like, sir, that is a total. Why do you got to use these big fancy words when you could have just called it a total? Right? Marginal frequency, what's it mean, kids? Total! Total! All right. Okay on the first page? Let's get going on the second page. I really like this second one right here. This second one's a pretty interesting example. Example 2 is a great example. I love example 2. All right. I want you guys to take a second and read example 2 I've got to get my column in here. We're going to go ahead and construct a two-way table for this short paragraph of information up here. And I want to see if you guys can help me fill all these values in. What I'm going to tell you is this. We need to label this before we even start. The values up top here for yes and no, I'm going to kind of put a box up here. These are the number of kids that are taking art. All right? So art is going to work in a column format here. And then I'm going to put FL down here for foreign language for the number of kids that are taking this right here, okay? I want you guys to read through that paragraph, maybe take a second and talk it over with the neighbor. I'm going to see if you guys can help me fill some values in this two-way table based on that paragraph. So take about 1 minute right now, read that paragraph, and then with a partner, tell me what values you could at least fill in to start with, okay? All right, kiddos. Thoughts on how this information might get filled in? Any number or any cell up there that you were able to fill in right off the bat?
The total is 248.
Okay, so the total group size is 248 students. We know we're talking about total group size of 248. So which of the cells that are blank up there, where would you throw that 248, guys? The very bottom right. We know that we're talking about total group size of 248 students. Very good. Now, next sentence right here. 175 students take a foreign language. So foreign language goes by rows. Yes going across. Don't confuse this with yes and no, but it says foreign language people. How many total kids are taking a foreign language over here? 100 and? There's 175 kids taking a foreign language. This says go by rows. Foreign language, yes. Total's 175. Now, the question becomes this. If they're taking a foreign language, of those 175, how many did it say we're taking an art class?
36.
So what do you have to put here?
36.
Okay. So if I read this row, forget the up and down for now, it says there's 175 kids that are yes to what?
Taking
Foreign language. And they are also yes to what? Art. Does that make sense why that 36 is there?
Yeah.
Okay, then the next sentence says 22 of the students, they do not take foreign language, they do not take art. 22 of them, not taking English, not taking art. So is there any way that I can place that value 22 there? In the no column. So art no, for art no, moving down, intersects with foreign language moving horizontally. So do you guys agree right here's my 22? Okay, well, once I'm done with that, that's all the information. That's all the numbers they gave you in the story, right? Is there enough information here then to complete the table?
Yeah.
Let's do it. Somebody start. Where do you want to start? So you're going to go ahead and start in this far column right here. You're going to go 175 from 248. So 248 minus 175. How much is that?
It's 73.
73. Okay. So this right here means 73 people did not take what? Foreign language. 73 people are not taking foreign language. Okay, so once 73 is identified, what could I do next? Say that one more time, Anna.
Subtract 22.
Okay. 73 minus the 22 in this row. What is that?
51.
Okay. Where else can I fill in a cell at?
Subtract 175 from 36.
So 175 minus 36, and you get 139 right here, which means that there's 139 students that take foreign language but not art. Okay? How about this column right here then? Add these up, you get 87. Guys, tell me the what's the meaning of 87 right there? 87 kids are in art. Add that up. 161 means 161 kids are not taking art. You know, you'll know you've done stuff pretty correctly if the following is true. Somebody total 87 and 161 for me.
248.
Ah, works. 175 and 73. This row right here, this column, they total up the same value. You've done something correctly there. All right? So guys, when I start talking two-way tables and joint frequencies, and you find the joint frequencies and the marginal frequencies, that's a bunch of hippy-dippy baloney. All they're really saying is add and subtract to find your values in the table. That's all you're doing. All right? That's all you're doing. We know how to add. We know how to subtract, right? Joint frequencies, marginal frequencies. It's all addition and subtraction. Right? Okay, good. Sorry, I need to settle down, but I can have another cup of coffee if that's okay with you guys. No? Lane's looking at me like, don't you dare, Parson. All right. Well, let's rock and roll. So if I ask you guys to construct a two-way table, can you manage that? It's just filling in a bunch of unknowns, addition, subtraction-wise. Okay? Example 3 might be where things start to get a little goofy for you. All right? This is where things start talking about finding, and here we go. Relative frequencies. I'm going to underline a phrase right here. You might want to do that before I read this. Okay? This is what this is about, and I'm going to give you a shortcut to this. Guys, the two-way table shows the results of a survey that asks college-bound high school students whether they plan to go to an in-state college. It says make a two-way table that shows the joint and marginal relative frequencies. The joint and marginal relative frequencies here, okay? When we're showing stuff that's relative, the word relative simply means pretty much turn stuff into a percent. Let's complete this table right here, gang. Let's complete this table. How many are yes to an in-state college after graduation? What's this total? 346. All right, let's fill this in. And how about right here?
294.
294. Okay, let's do our rows now. 142 and 170.
312.
312. 204 and 124.
328.
So right down here then, what's the total group size? What's the total group size of that junior senior class that we surveyed?
640.
640. Okay. So I'm going to go back to the previous page. Do you have those values in there first of all? Have those values in there? I'm going to go back to the previous page here real quickly, and that first example said, hey, find the marginal frequencies. Find the totals right here from the joint frequencies that were already in here. Okay? The information that was either junior, senior, or yes or no about riding a bus. Take these joint frequencies to total up to a marginal frequency. Now, here's the situation. Instead of talking about just joint frequency or marginal frequency, they throw a word in here. This word, relative. Anytime they talk about relative from now on, think of relative as like a percent as a what? Decimal. Anytime you hear the word relative, anytime you hear the word relative, percent as a, that kind of hurt, decimal. All right, Clayton's looking at me like I'm kind of goofy. You know what? Clayton's right. All right, and that's okay. Here's what you're doing. I'm going to zoom up a bit on this. All right, kiddos, here's what we're doing. Here's what we're really doing. We're going to take all of these values. We're going to take all of these values right here and kind of turn them into a percent as a decimal. What's the total size of the group, guys? 640. What we're really doing here is the following. We have how many juniors that are saying yes to an in-state college? 142 out of a total how many? So to find the marginal relative frequencies and the joint relative frequencies here, you're simply going to turn basically everything into a percent as a decimal. In other words, you're going to take all these values and divide them by What total?
40.
So my juniors right here, check this out, guys. We're going to go 142 divided by 640. What do you get as a decimal?
22.
I'm sorry, how much?
22.
So 0.22, is that right? Okay. And we'll leave them as a decimal. Or, yeah, as a decimal. 0.22. All right. Seniors, what are you going to divide for seniors? 204 by 640. Oops, I didn't want to do that. Let me make this look better. 204 divided by 640, is that right? And what did you get for that frequency? 0.32. So guys, for the marginal relative frequency down here of the number of students that say yes to a four-year college, or I'm sorry, an in-state college, what are you going to do with the 0.22 and the 0.32 to get a total down here? Add them, which would be 0.54. What this is really saying is this. This is really saying 54% of the students are probably planning on college. Does that make sense to you guys? All right, let's do the no's. Let's do the no's column. Like the N-O, nose, not the nose, smelly nose, the nose. Okay, never mind. 170 divided by what? 170 divided by what?
640.
What do you get there, kiddos?
0.27.
Point, which what? 0.27. And how about the joint relative frequency of the seniors that said no?
0.19.
It would be 124 divided by what?
640.
And I'm guessing, hang on, 54 and 27 is 81, so hopefully 0.19.
Yep.
0.19. All right, I agree. All right, now I want to show you the significance of marginal relative frequencies. Tongue twister. Marginal relative frequencies. Kiddos, if I'm talking about all 640 students here in that table, what percent of the students am I talking about? All 100% of them, right? If I'm talking about every single student being surveyed and figuring out what they're doing, I'm talking about all 100% of the students, right? Every one, 640 of them, right? All 640 is 100%. You guys agree with that? I want you to go ahead and take a look with me at these totals now. So help me with this right here. Let's go across. Let's go rows first. Go 0.22 plus 0.27. What is that? 0.49. How about 0.32 plus 0.19? 0.51. Let's do the column down here. 0.27 plus 0.19. Guys, here's the significance. Again, these are all percents as a what right here? Decimal. When you do the sum of this column right here and the sum of this bottom row right here, your totals, what's the total sum? 1. 1 indicating what percent? 100%. So when you're looking at marginal relative frequencies, you'll know you've done this table correctly if your totals right here are always what value? 1. Okay? Marginal relative frequencies. When you hear the word relative, they're basically saying turn stuff into a decimal. Turn stuff into a decimal. Word relative, turn stuff into a decimal.
It's impossible.
Okay?
It's impossible. It's impossible.
Nothing's impossible.
A 4-piece paper like 7 times or 6 times.
I bet I could do it.
And some big
Oh,
piece of
regular
paper
piece of
is
paper.
actually proved that you can.
Okay, 2 more problems. Let's run through these quickly. Okay, so the part that's really new then is conditional relative, okay? Anytime you see the word conditional, you're not using, conditional simply means you're not using,
Just fold it, you fold it over, so just fold it, fold it, and fold it, and fold it.
means you're not using a whole total. Guys, I need help right here. If you'll go back to the table in example 3 and tell me about the kids that are planning on four-year college. How many kids were here as juniors that were taking that on example 3? Was it 124?
Yeah.
142? Junior, yes.
Yeah, 142.
And junior, no for me, Anna.
204. Or, no, 170.
170? Okay. I'm going to fill these totals in. And seniors, yes.
204.
204?
Yeah.
And seniors, no.
124.
All right, this is the part I want to talk about. Now, guys, we've had totals in this column and in this row right here. And if you can kind of imagine a cell right down here being your group total right here from now on, that's what we were dividing before when we talked about marginal relative frequencies. We were always dividing by a total to get that joint relative frequency to sum up to your marginal relative frequencies. Now, guys, this last example talks about finding a conditional relative frequency, and here's the difference. We're going to use that survey that we just looked at to make a two-way table that shows and here it is, the conditional relative frequency based on the, what's it say here, guys? Column totals. Column meaning up and what? Up and down. Okay, so here's how this works. Let's find the totals of each column. So I'm going to put a total down here. Okay, so how many kids were planning on college when I add these two values up in that yes column? How many were planning on yes? Total. 346. And then, how many total in the no column? Okay. What conditional relative frequency means is the following. It simply means, all right, you have some kids that are saying yes, and you have some kids that are saying no. This would be a great tool. This is simply saying right here, of the kids that say yes, right here, the kids that say yes, how many total kids said yes?
3, 4, 6.
Okay, they call it conditional because we're going on the condition that the kid is saying what to going to college. They're saying yes. They're saying yes. So I want to know what's the conditional relative frequency. Let's see, that word relative means turn everything into a what? Decimal. Well, how many juniors are going to college, guys? 142 out of the number of people that said yes, 346. So you're simply going to take 142 here and divide it by what? 346. So what do you guys get as a decimal there?
0.41.
0.41. Okay, and we'll talk about what that means here in a second. How are you going to find that for seniors?
Okay, 204 divided by 346.
I'm not very good at math, but I'm going to guess that's about 0.59.
Yep.
What's that? I heard that. I heard that. Look, just because I'm a math teacher doesn't mean I don't stand up here and just fill you with a bunch of stuff that you guys believe. Like, I got to tell you, aliens built the pyramids. And you believe that, because I'm a math teacher. I believe it.
Say who on the
No,
table?
when I want to know what pyramid, you ask my parents. So I know pyramids as well.
Okay. Hey, quick question here, guys. What's 0.41 and 0.59 add up to going up and down in conditional relative frequency? What's this add up to?
1.
Okay, what this means is this. It means of the 346 students planning on college, what percent of them are juniors? And what percent are seniors? 59. That makes sense to you? Okay, let's talk about the ones that are no's right here. Now, instead of dividing by 346 for this column, you're going to take these values, 170 and 124, and divide by what? 296. So let's do that. 170 divided by 296 here. What's the condition that, hey, we're not going to college. So what percent of the people that are not going to college are juniors? What percent of the people that are not seniors are going to college? So we're going to take that 170 and divide by 296 as a decimal. How much?
2.57.
0.57? So 57% of the kids that are not going to college are juniors. Of the kids not going to college, 57% of those are Juniors. Anybody have a guess on what the next one's going to be?
Wait,
Yeah.
296 or 294?
It's 294.
Oh, shoot. Thank you. Let me fix that, okay?
I noticed that, but I didn't want to say anything
Because I'm the math teacher.
wrong.
And I'm never wrong, right? Thank you very much, Anna. Woo. Too much coffee. Blew right over that one. One flew over the cuckoo's nest. This is the cuckoo.
Then juniors would be.
All right, so let's do that. 170 divided by 294. My mistake. So rewrite that again. What is that going to be? 170 over. Do we agree on everything else then, Anna?
Yeah, it's 0.58.
0.5 what?
8.
0.58. Okay, so let me fix that. 0.58. And then the last one, we're going to do 124 divided by 294, which is going to be 0.42. 0.42. And again, these two, this time in conditions, add up. All right. So, conditional probability. Conditional probability is not based on the overall group size total, but it's based on the total in a column or in a row. It's not that bottom right-hand cell value, okay? Guys, are there a lot of terms that are new? That's my first question. But is the concept pretty simple? It's just a bunch of addition and subtraction and division, isn't it? It's just a bunch of addition, subtraction, and division, isn't it? Okay, so let's get this last example and then get you some time to do some stuff. Actually, we'll finish this up and we'll be done today. All right, example 5 is the last one I really want to talk about. It says recognizing associations in data. It says the two-way table shows the results of a survey that asked students whether they watched animated movies. I love animated movies, by the way. My last good one that I saw, I took my girls to, The Good Dinosaur. Anybody, have you guys gone to The Good Dinosaur, anybody? It's a good movie, isn't it? It's a good movie. Okay, the two-way table shows these results. So guys, kids that are 12 to 13, this is a survey. How many in that survey said, yep, I go to animated movies. I like them. Or I watch them.
52.
And how many said no?
18.
My question is this, how many total 12 to 13-year-olds are in that sample size?
70.
Okay, so we want to go ahead. This CRF percent stands for conditional relative frequency. What percent of 12 to 13-year-olds are going to see animated movies? So what I want to do is take 52 and divide that by
18,
70. 52 divided by 70, the total number of kids. You understand where that 70 just came from? The 52 plus what? 52 out of 70 say, yep, I'll see them. So let's punch that up. Let's see what this gets us. I'll move this over here. Okay, so 52 divided by 70. Let's turn this to an actual percent. What percent would that be if I move 2 to the right?
74.
About 74%. Okay, I'm going to put the rest of these up here. This is going to be 31 over 50. Can I just tell you where I got the 50 from? Or you tell me. How's that sound? 31.19. So there's 31 out of 50 going. I'll just tell you that this is 62%. How about the next one? Well, this is going to be 37 out of the sum of 37 and 38, total is 75. Would somebody volunteer to punch that in for me as a percent? Go, Clayton. Go, Clayton. Go.
49%.
49%?
Go to the other one. Let's get another total.
58. There's 15 that said, yes, I go to the movie, out of a total 58.
25%. Why did you round up to 26?
About 26%. Okay, so let's take a look at this conditional relative frequency table right here, guys. Looks like to me, as kids are getting older in age up here, these are the age ranges. These are the age ranges up here. What's happening to the number of people in those age ranges? What's happening to your percentage as time goes on, or as kids are getting older? So, what can we conclude about this in this table right here?
People are losing their minds. Kids.
People are, the older the kids are getting, the less they are watching what type of a movie?
Animated.
Okay, so the older the age range, or the older the kid, comma, the less you're watching, the less animated movies are watched. Okay, so that would be a good summary to that. So, guys, again, a lot of terminology here, but you need to understand. If they ever use the word relative, you want to turn everything into what? Decimal. Okay, if they don't use the word relative, then just put your totals in there. It's just a bunch of addition, subtraction, and division today. That's all those terms mean. And that's easy. Okay, questions at all? Don't forget your take-home quiz is due what part of the hour tomorrow? The beginning, the 9:35-ish. Okay, beginning of the hour. Okay? You guys have a wonderful day.